Okay, so this is question number 4 from TEDET 2018. We have an hour, right? And we're probably going to go through like 5 or 6 questions. I'm going to give you kind of like 5 minutes to thinking time first, 3 to 5 minutes depending on the question. So we have A, B, C, 3 points. M and N are midpoints. So M is the midpoint of A and B. A and B. So we're looking. Oh, awesome! I think someone gave me a thumbs up. So we're saying this bit is equal to this bit. N is the midpoint of B and C, right? So we also have this and this is equal. And we say that AM is 5 and AN, this whole bit, is 12. We're looking for the length of AC, so like the whole line segment. Does anyone want to like give a solution? This is a great chance for you to kind of practice your presentation skills and whatnot. Okay, so we know that AM is 5, right? And if this is 5 units, and we say that M is the midpoint of A and B, remember? That just means that AM is equal to MB. So if this bit is 5, this bit must also be 5. And then like, you know, with these questions, I think it's quite nice just to kind of work through the question step by step, and then eventually we'll kind of reach the answer. Just kind of thinking about finding all the lengths possible. We're thinking, okay, what's BN now? Well, BN is AN, which is 12, minus AB. Well, AB is 2 bits of 5, right? So it's 5 and a 5. 5 and a 5 is 10, 2 bits of 5. So this is a 10. If it's 12 here and we have 2 bits of 5, which gives us 10 here, it must be 2 here. Is that okay, everyone? That must be 2. Now, N is the midpoint of B and C. So if BN is 2, then NC must also be 2. And that now gives us the answer because we want AC, right? There's lots of ways now you can think. AC is 5 plus 5 plus 2 plus 2. You can even think of AC as this whole 12 plus the 2. Essentially what you get out is 14. Because it's 12 units here and 2 units here. So the idea here is that, you know, just like remembering what midpoints does. This is the midpoint. Essentially means that this bit and this bit must both be equal. This bit and this bit must both be equal. That's 5, so that's 5, 2, 2. Okay, next one. Oh wait, I should say a bit more. Well, I think like if you want to like kind of like think through this question a bit more, then you can think like, well, I want AC, right? And I have AN already, and AC is AM plus NC, right? If I want the length of AC, and I know AN, I just need the NC. Well, NC is equal to BN because N is the midpoint, right? So NC is equal to BN. So if I want NC, I want BN. And you can kind of do this kind of backwards thinking and think, okay, if I want BN, I will want AB. And if I want AB, I need MB and all that kind of thing. So you can also think like, okay, from what I know AN is 12. What else do I need to know in order to find the whole thing AC? The whole thing AC comes from AN and NC, AN and NC. I know AN, so I'm probably looking to find NC here. Okay, how can I find NC? Let's work backwards from there. But yep, okay, not much to say. Okay, next one. So I'll probably give you 3 to 4 minutes, 5 minutes for this. A, B, C, D are point sets shown here. M straight lines that pass through 2 points from the given 4 points. And there are N rays having 1 point from the given 4 point as an initial point, and the direction is determined by another point from the rest of the given point. Okay, might be a bit confusing here. The word ray essentially means if I have 2 points, right, I can draw a straight line through it. Everyone knows that. You can draw a straight line through the 2 points. If I'm talking about ray, a ray is essentially a straight line, but it has a direction. Think of it as like an arrow. A ray has to start from some point, and then it goes in some kind of direction, like that. So essentially what they're saying here is that the N ray is having 1 point from the given 4 point as an initial point, right? So we're thinking, okay, maybe I take A as my initial point. If A is my initial point, then my ray is kind of going from A out. If I pick C as the point that it goes through, then it would be this kind of ray that goes from A and goes through C like that. If I'm picking A to be my initial point, and then say D or B as the point I want it to go through, it's going to start from A and it's going to go through B like this. Another possibility is, of course, I could start at D, and I want an array that goes through B. It would be something like that, or D through C. That could be another one, all that. So we're looking for the value of m plus n. So all the number of straight lines that we could have, and all the number of rays, remember, think arrows that we can have. Okay, so and if you count all of that, you'll get 12. Wow. So we have 6 for m, 6 for the lines, and 12 for your rays, which are essentially lines with directions. Think of rays as rays is essentially, think of it as a line with a direction. Think of it as an arrow. Okay, first, are we clear that the answer is 6 plus 12, which is 18? So the answer is 18. Now I'm going to show you a slightly quicker way of doing this. We already counted the number of lines, right? And we got 6 for the number of lines. I'm thinking for each line that you have, say a line that goes to A and D, you can think of each line representing 2 rays, because A and D as a line can be thought of as the ray A to D and the ray D to A. So for every line, you get 2 rays. If I draw A, D, right? This is one line, right? But when I count the line, this is one line. But if I'm thinking of rays, this can be thought of as 2 rays. I can think of it as the ray from A to B, or the ray from B to A. So essentially, we have this kind of thing where one line equal to 2 rays. So if we have 6 lines, we're going to have 12 rays, because one line is 2 rays. 6 lines, 6 times 2, 12. So we're going to get 12 rays. 6 lines, that would give us 6 times 2, which is 12 rays. So altogether, we have 6 lines plus 12 rays, which would give us 18. So that's another way to think about this. Definitely that slightly harder, but it's actually much kind of easier to do. Okay, one last way of doing this. There's a lot of way. Now, if we think about, let's say, counting the rays first, what's a fast way of counting the rays? Remember, rays are arrows, right? Lines with directions. There's another way, by starting with just counting rays first without thinking of the lines, and it will count the lines later. One to do it is okay, we're going to pick. Let's pick. So first, array, remember, we need an initial point, right? And then we need to choose one more point from the rest. We choose an initial point, and then we have 3 points left. We choose another one. And then from the initial point, we draw an arrow down. That's what array is, right? Okay, so let's say I choose any initial one. Let's say I choose A. I have 3 remaining points, right? I have 3 points left. So there's 3 ways of me choosing which direction it's going in. It can go this way, it can go this way, this way, or it can go this way. So if I pick A as my initial point, I have 3 points left. That's going to give me 3 ways of choosing my direction and therefore choosing my ray. So can you see, if I choose A, I'm going to get 3 possible rays. If I choose B, same thing. I'm going to get 3 possible rays as well. If I choose B as my initial point, I'm going from B. I can go A, I can go D, I can go C. So if I choose B, I also get 3 more ways of creating a ray. 3 rays here, 3 rays here. I'll also get 3 rays that come out from C. C coming out. And I'm also going to get 3 more rays coming out from B. So I'm going to get that. So for each initial point, every time I pick one initial point, my first point, I get 3 remaining points, and that gives me 3 rays. So for every initial point, I get 3 rays coming out. There's 4 ways of choosing my initial point. I can choose as A, or B, or C, or D. So that's going to give me 4 times 3. There's 4 initial points, right, that I can choose, and 4 possible starting points. Or I can choose B, I can choose A, I can choose B, I can choose C, I can choose D. I can choose D, C, B, A. So there's 4 ways, and for each of my starting point, I get 3 rays each because I can draw down 3 ways. So together, I'm going to get 12 rays. I said that like one line leads to 2 rays, right? So same thing here. If I have 12 rays, that should be equivalent to giving me 6 lines. Remember, like 2 rays will give me a line. 1 line will give me 2 rays. So if I start here and I get 12 rays, I should then get I will get 6 lines. If I get 6 lines, that's M. 12 is the other one. Add them up together, you get 18. Okay, awesome. Any questions? That's kind of 3 ways of doing it. I know it's a bit like you might think it's too hard to do it this way, but it's nice to have like lots of ideas with these questions. Awesome. You got the answer 16, yeah, but okay. And how do you work that out?
I do like draw a square.
You do, so you do a square, right? Square, okay.
Yes, the largest area is square. Each
Okay.
side is 5.
Okay.
And the smallest area is rectangle. Each side is 1 and 9.
Good. Okay. So essentially we're saying we have wires of length 20, right? So if we want to squeeze the wire into some kind of rectangle, like bend the wire, then it has a perimeter of 20, which means if I call this the length, if I call this the length and this the width, I have that length plus width must be half of the perimeter, which is 10. And as you pointed out correctly, the largest area, this is where like you can actually just try it out, like length width. Just put in 1, 9, 2, 8, 3, 7. We can actually stop at 5, 5 because after 5, 5, we're gonna get like 6, 4 here, right? And 6, 4 is gonna repeat with 4, 6, and it's essentially the same one. So we don't need to do that. So we stop there. And then for each one, you can just work out the area. Area is length times width, right? This times this, and then work each one out and check which one's the largest. It's as you pointed out, I'm not sure if you know this already. If you do it, that's great. But with these kind of thing where you have like a fixed perimeter, the square is always going to give you the largest area. It's just how it is. But if you don't know, you can definitely just try out every possible value. And remember, they say that the side must be integers, so that saves us from having to do stuff like 1.5 here, which would be really, really bad. Like, so I don't have to do stuff like 1.5 or like 2.5, 3.5. Yep. Oh, and this is not related to this, but if you have a fixed perimeter, do you know which shape gives you the largest area in general? Obviously, you can't do it with this question, so it's not about this question. But like in general, the circle will give you the largest area. If you have some like fixed perimeter, the perimeter must be 20. Then the circle will give you the largest area. Even just something. Keep in mind, that's pretty cool. Yeah, so essentially you have largest area is 25. Not a great 25, but that's 25. And smallest area is 9.
Yes.
25, smallest 9. Difference must be 25 minus 9, which is, as you say, 16. So, yep, so there you go. So answer must be 16. Someone wrote 14. Not quite. It's 16. Maybe you just made some mistake when you did subtracting, but it's 25 minus 9. Subtraction gives you 16. Okay, awesome. I think I'll stop there then. Okay. First time's up. You can take it as homework. You kind of get what this means. This is like some kind of 3-dimensional shape. Imagine you have these kind of small cubes which you put up in Lego, and you get this kind of like shape out, and you're looking at it from like the top. This is what it looks like from the top. This is what it looks like when you look at it from the front.
Yeah.
looks like from the side so แบบมุมบนมุมอะไรวะมุมหน้ามุมข้างด้านข้างด้านบนด้านหน้า and they're asking how like how many possible constructions are there altogether so something like this one hint I'll give for like these kind of questions this is from the solution actually but it's quite nice to think okay to top view just think like what is the possible number of like blocks that you can have on each of the grid so like or like this grid remember this is from the top right like how many possible blocks can I have is it possible to have like 3 blocks here
ก็เนี่ยเคยดูถ้า
or is it like 1 block here is it 2 blocks here so just thinking like from each of this area how high is it is like this bit is it like kind of 3 blocks stacked together is this bit maybe 4 blocks 5 blocks like and using these other information to help you yeah so like it's easiest to kind of think like okay maybe let's say this block here this is from the top view right so you don't know how high it actually is and like think like what's the possible number of like what's the height here is from this do you get 3 blocks stacked that area do you get you know thinking of that might help you figure out so that's probably it so thank you so much for coming hope you got some stuff from it hope you give this question well awesome thank you